Okay, so this is the recap about yesterday's session on the dependencies. Public subnet, private subnet, route table, internet gateway are dependent on VPC, and Elastic IP is not depending on any other resource. NAT gateway is dependent on Elastic IP and internet gateway, and we publish NAT gateway into the public subnet. So all the steps are mentioned here clearly, and you can see the resources here. Okay, so today the session is about state, remote state, and variables. So let's decide one name for our project. Okay, so let us name it as timing. Project name is timing. Okay, since I told you already, we are working on a 3-tier architecture application that shows the current time in the browser. Okay, so project name is timing. Let's decide this, and I will create session 3 here. So let me copy provider. So first thing you should do whenever you do the Terraform is create the provider. Okay. VPC and provider. I'm just copying these two to session 3. Provider and VPC. So let us name this as timing. Okay, and then let's take care of this later. So let us create the infrastructure first and understand the state. PD Terraform session 3. Terraform init is the first command. After Terraform init, Terraform plan. It is saying 10 resources are going to be created. Then let us do Terraform apply. I'm just giving auto approve instead of saying yes in the console. So it started creating. Now let us discuss something. State and remote state. So, Terraform is a declarative way of approach. Terraform is a declarative way of approach. Declarative means whatever you write, you will get it. Provided you follow proper syntax. So that is the meaning of declarative. Not only Terraform, anywhere if you listen the word of declarative in IT, it means whatever you write, you will get that. That is the guarantee from that specific tool. Okay. So still creating. Hope it will be over in few seconds. So what happens whenever Terraform creates infra, it will create a file called terraform.tf state. Terraform.tf state. It's done. So what is this terraform.tf state? TF files is equal to whatever we want. It is like required infra. So TF, this one, terraform.tf state is equal to created configuration or else current state of the configuration, current state of infra. Okay, we asked this one through TF files. Then Terraform created some infrastructure. So it needs something to track. Okay, so it need some way to track what it created. So that is nothing but terraform.tf state. So this is the one created by Terraform. If you go and check terraform.tf state, you can check here. So this is the resources it created. It says, you can say this, it is created AWS EIP. And then you can check all the details of that here. What is the IP it created? This is one resource. List of resources. You can see a list of resources. And the next one, it is created AWS Internet Gateway. And next it is created AWS NAT Gateway. And it created route table. And it created another route table. This is public. And it created route table association. So it will keep a track of whatever it created through the terraform.tf state. Okay. So ideally, the Terraform responsibility is to match these two configurations one by one. So required infra should be always equal to created infra. So that is the responsibility of Terraform, right? So Terraform.tf state is for the Terraform purpose to track what it created. So always Terraform makes it 100% matching of these two things. Suppose when I go and change something here, for example, I'll change here something. Change. I change the name. So now you run Terraform plan again. So what it is trying to do, it is trying to restore back. So I said it will match the TF files and it will match the TF files with the created infra. Then, so now whenever you do some change, what it understood is it will get this terraform.tf state and it will try to check whether it is the same in the console. Okay. So now it will understand something is changed. Okay, someone changed it manually in the console. Then it will try to replace that change. Terraform apply if you do. It will try to revert the change actually. Yes. So now it is the proof. Terraform will always try to maintain the state whatever you ask. Now we have seen I did some change intentionally in the console. So now whenever you run Terraform apply again, Terraform will get the terraform.tf state and it will compare. It will compare, then it understood like, so there is something changed. I need to restore back to the declared infrastructure. Okay. So that is the usage of state file. Terraform use the state file to always compare the declared infrastructure is equal to the created infrastructure. I can say instead of required, it is desired state. And this is actual state. So these should be same. Desired infrastructure should be same as actual infrastructure. So this is the terraform.tf state. Right now we have it here. There are few problems if you keep the terraform.tf state in your local. If you lose this terraform.tf state, then Terraform will not, there is no way Terraform will understand what happened earlier. Okay. If you remove this file, then Terraform will really not understand what is happening. For example, now I will remove and I saved. Now you go and run it again. See, it is trying to create again. Okay. So that is a problem. The problem is keeping terraform.tf state in local is a problem. If you lose the data, then Terraform cannot track what happened earlier. It will try to recreate. Okay, and this is one problem. And you know, Terraform is used by multiple persons in the team. For example, infra team is there. There can be multiple members. There can be multiple members. Every person will contribute some work. So now let us see what will happen if you use Git. So for collaboration, we use Git, right? So we use Git for version control. Okay. So now what I will do is I will remove this infra. I will destroy and then we will see. Terraform destroy. Auto approve. It is destroying. Now let us see some scenario. So infra is a big team. Multiple persons will be working on infrastructure project. So we will use Git for version control. Now let us say engineer 1 joined and he cloned the repository. He cloned repository and engineer 2 also joined. He cloned repository. So this is the steps. Engineer 1, he applied Terraform. And engineer 2 also, he will also apply Terraform. Now let us see what happens. Okay, I am pushing this to Git. So I'll take another bash. This you just imagine as engineer 1. Take another bash. This you imagine as engineer 2. Okay, now they cloned. Now they will clone the repos. Just assume they joined newly. They are cloning the repos. Git clone and git clone. Okay, and engineer one is doing Terraform apply, auto approve. Okay, cd Terraform Session-03 Terraform. Okay, we run Terraform in it. Terraform apply approve, and engineer 2 also, let us do, is also doing same. So engineer 1 is creating the infrastructure. Terraform apply auto approve. Then engineer 2 also creating the infrastructure. Now let us see what happens. If you go here and then check. This you can see duplicated infrastructure is getting created. Why duplicate infrastructure is getting created is because if you go to engineer 1 folder, he has one Terraform TF state. Let us complete this. Let it complete, otherwise we'll get error. So if you open this Terraform TF state, so it is created and everything is duplicated here. Okay, everything is created to two resources. Okay, why? Because when engineer 1 is creating Terraform apply, then it will create one Terraform TF state. And when engineer 2 also doing the same thing, it will also create one Terraform TF state, making the duplication. Okay, so this is not we want. So what we want is a central place. So a central place where Terraform can understand the created infra or the actual infra. If you keep Terraform.tf state in local, then Terraform may create duplicate and Terraform will give you an error. Okay, so that is why we have something called as remote state. In this remote state, what will happen is, so here he is engineer 1 and he is engineer 2. So when he applies, it will state a state file to S3 bucket. Okay. And then infrastructure will be created. When engineer 2 also applies the Terraform, then what it does is it will compare with this remote file. Okay. So here two problems. Multiple persons should not change infra at a time. Okay. Only one change at a time is allowed. That is one advantage. And the another advantage is duplication and errors in Terraform will be removed. Okay. So that is how we should use remote state. If you keep the state in local, Terraform will always try to create the duplicated infrastructure. But if you keep it in a central place like S3, whenever you apply Terraform will compare the state with this one, with whatever is available in S3. And when second person also try to create the same infrastructure, then it will go and compare with S3 file, whatever inside the S3. Okay. And when to prevent this multiple persons or applying the infrastructure at a time, what we do is we will lock it using DynamoDB. Okay, so what is this locking is when you do Terraform destroy auto approve, you can see a log file is created here. You can see terraform.tfstate.log.info is created. Why? Because Terraform is already applying some changes to the terraform.tf-state. So you should not try to open this. You can see here, you should not try to open this. You should not do any edits to this file. So that's why we have log file here. So similarly, whenever you lock the S3 bucket with DynamoDB, it will not allow another person to run at the same time. Okay, we will see this configuration now. I'm going to create one S3 bucket. I'll name it as timing remote state. That's it, create bucket. Okay, and then we need to use DynamoDB also. DynamoDB. Here, go to tables and create a table like timing lock. You need to use this LOCK ID. Partition key should be lock ID. So this is the default thing. You need to create one S3 bucket and you need to create one DynamoDB table, and then you need to configure these two. Lock ID is a default name you should use. And I created a bucket. Now, how can I say Terraform that keep the state inside the log file is? Now let us clean up these two. Terraform destroy auto approve. Let's try this one as well. Okay, we did some nasty things in the UI. Let us go and check if the VPCs are here or not. PD session-03 and then destroy. Okay, so all the things are deleted. Now let us understand the state part. So inside provider, you should tell Terraform that don't store the state in local, store it in S3 bucket. So that configuration, we can just get it from internet. Terraform remote state S3. So we call it as backend. Okay, just copy this backend S3 and inside Terraform block, you need to give like this backend S3. What is the bucket name? Timing remote state. Okay, key you can give anything. I'm just giving it as timing. Region is AP South 2. And you need to mention the DynamoDB locking as well. So that one is just DynamoDB table. What is the DynamoDB table? Timing hyphen lock, I think. Timing hyphen lock. This is the one. Okay, so this is how I'm telling Terraform. Don't store the TF state in local. Okay. Store the TF state in S3 bucket, that is timing remote state, and lock it with a DynamoDB table like this. Okay. Now let us go to the console here and do Terraform init. Okay, what is the region we created? This one, timing remote state is AP South 2. This is fine. Valid AWS region. Why it is invalid? AP hyphen South hyphen 2. is the error here? Okay, let me create the bucket in now. Should not say like this actually. Maybe this is a new region. That is why we're getting this error. Let's try to remove this and then check. Okay, let us create in another region instead of waiting for this. Let us create timing backend S3. Let us create it in Mumbai. Bucket versioning, enable it, and then create tables. Also, let us create another table. I think table is in Hyderabad. Let us check in Mumbai. Timing lock, and then lock ID, create table. Give region equal to AP South 1, timing backend S3. Terraform init. Maybe some problem with Hyderabad region since it is new. Just for S3 bucket, to hold that state, I created in another region. Okay, Terraform backend S3. Now you do Terraform apply. So you can come and check here. There will be, once this is over, you will get a key here. And then in the table, explore items, you can check a lock ID is created. So how much time this will be here until the Terraform apply is available? Until Terraform apply is running in the background, you will have a log file created. Okay. Once that is over, this will be deleted automatically. Let us wait for 1 more minute. Okay, you can see it is completed. Then you got a file timing. When you go and check here, this should be removed automatically. But it's fine. UI will have some slowness always, but it is deleted in the background. Okay. So now we will check this one. Just download. And open. So this is the state file. Okay, so now let us try to do the same thing as we did earlier. First, let me push this. Okay, and then I'm cloning this again. And engineer 2 also, I will do that again. Okay, and engineer 1, he do Terraform init. And here also he do Terraform init. Okay, and now let us do Terraform apply from the engineer. Okay, and here also from engineer 2, let us try to apply Terraform. Okay, it is done. Okay, so what we do now is let us destroy this. Because here a small change this one and you cannot see the actual difference. Let us destroy first and then create this infrastructure from the scratch, then you will understand. Always this NAT gateway is taking time to create and then delete. Almost 1.5 hours. So almost 1 hour, 30 minutes, so 30 seconds, 1 minute, 30 seconds. So if you have this much gap, like 1 minute, 30 seconds, then we can really check what is happening in the background. Okay, now it is destroyed. So just assume engineer 1 is doing the apply. And engineer 2 will also do the same thing. You can just see engineer 1 changes are still applying. Okay. In between, engineer 2 has done something, then you are checking this. it got the error acquiring state lock, because it means there is one person already running the infrastructure. You should not run this again at the same time. That is the error. Okay. So now this goes and change the state to S3. So once this is completed, again, engineer 2 can run it. Till that time, a lock will be available here. Okay, you can see another lock. This one, this is the one actually. Whenever this is visible, it means someone is running the Terraform changes, either create or update or delete. Something is running in the background. Once this is over, then this lock will be deleted. This is the lock ID actually. Okay, now this is done. You can come here and refresh. Actually, that is gone. Now you go and apply from the engineer 2. Then it will say, now engineer 2 infrastructure will be compared with the state file in the S3 location. Now you can see there are no changes. Okay, literally there are no changes. It means the resources are not duplicated. So that is the usage of remote state configuration. Now you will face this question. Explain the state in Terraform. You can say Terraform uses state file to check the desired configuration versus actual configuration. If you keep the state file in local, there is a chance of duplication of resources and errors. Always you should keep the state in the remote location like S3, and you should lock it with DynamoDB. So in that case, if one person is running the Terraform changes, then it will be locked. Another person cannot do any changes, and the state is always secured. So it is in a secured location. If you keep it in local, there is a chance of you do some changes with some intervention. Okay, that those kind of disadvantages are addressed with remote state locking mechanism in Terraform. You use any cloud, you can do like this. So from now onwards, we will do the state inside the S3 bucket. Okay, I hope you understand this. So I just want to show you what are the errors. I can just say directly without showing all these errors, but I just want to show you what happens at real time when you don't store the state in remote location like S3. So we'll write this information here. If you lose the data, then Terraform cannot track what happened earlier. It will try to recreate. That is one problem. When trying to, in case of version control, keeping the Terraform state in GitHub also causes problem while Intra is creating through CI/CD. Okay, we can create the infrastructure using the DevOps CI/CD pipeline. At the time also, it will cause the problem if multiple persons are working together. So it is best practice to keep the state file in remote locations like S3 for better collaboration between team members. Okay. So this is the state and remote state. So later we can move to the topic of variables. You know the advantages of variables. If you are repeating the values in multiple places, okay, then you need to do the change in all places. There is a modification. Okay, for example, one value you are keeping it in multiple places. If something is changed, you need to change at all places. Instead of that, we can use variable. If we use variable, change at single place, reflect everywhere. Okay, so that is one advantage. And keeping variables aside will save us from accidental changes. Okay, so I'll show this now. So this is a vpc.tf. So let us test drive first. Terraform destroy. See, I'm doing the CIDR block here. In future, if I want to change, then I should come here and then change. This is hard coding. This is hard coding, right? So in future, if I want to change this value to something else, you should come here and change here. So at that time, you may be accidentally changing something else. Okay, hard coding is not at all a best practice everywhere. So we need to keep it inside the variable. So in Terraform, there is something called variables.tf file. Okay, this name is reserved. Here you can mention the variable. This is the syntax, variable and CIDR. I'm giving this. And inside VPC, I want to refer this from the variable file, var.cidr. Okay, then you just keep here value, default value. Is nothing but 10.0.0.0/60. Okay, here I am making the value. So variable.tf file. We need to keep all variables. Okay, in variables, there are multiple types. To demonstrate that, so what I do is I'll take one ALB, Terraform ALB. In application load balancing, here we can get all types of variables. So let me take this. create a section called variables. Inside this alb.tf, instead of that, so I'll just remove this NAT gateway because it is taking a lot of time, right? So I'll remove this NAT gateway. And then this private route also. Just 1 second. Okay, let us go with this one only. So variables file, we need to keep all variables in a single file. And there are multiple types of variables, that is like string, map, and then number. Number means nothing but integer. And then Boolean. Boolean is nothing but true or false. Okay. Let us get through documentation. Terraform variables. So for any variable you are declaring here, you need to mention the type. Okay, type equal to string. Type equal to string. And let me remove this. So I declared a variable CIDR type equal to string. Now let us go and then apply this. Terraform apply. So I didn't give value anywhere. It is asking me to give the value var.cadr. What is the value? Otherwise, you can keep something default variable here. Default 10.0.0.0/16. If you don't define this default, Terraform will ask us at runtime. Okay. So I'm commenting here also. Now, instead of Terraform interrupting, you can give Terraform apply -var, and you can pass through the command line as well. How can I pass through command line? Terraform variables values from command line. So there is some syntax, that is -var and ;: key value pair, ;: CIDR equal to 10.0.0.0/16. You can pass like this. Okay. That is one way. Passing through the command line or keeping the default value here. Or there is one more file called terraform.tfvars. So this file is to pass the default values okay, here CIDR equal to, the syntax is like this, /16. Okay, inside variables, I'm just declaring the variable name and the type. Okay, this is declaring name and declaring type. You can keep default values here also, there is no problem, but the best way is to maintain variables.tf and terraform.tfvars both. Okay. Now, if you run this Terraform apply, So what happens at runtime is when running this vpc.tf, Terraform understands there is a variable. Then it goes to the variable CIDR and it will check the value for here. If it is not there here, then it will go to the terraform.tf vars. If it is also not there, then it will ask you from the command line. Okay, you can see this is the one. But always you can override from the command line. Now you can check here this one. So now overall, what is the situation is variables.tf is to declare variables. Terraform.tf vars is to provide default values to variables. You can always override values from command line. Okay. You can keep default values also here, but not recommended. Okay. So now let us go and replace all these things. And this one, this is like public. I'm just mentioning as public. And this one, let us keep it here. Variable public subnet CIDR type equal to string. And then what else? This tags is nothing but key value pair. Okay, this tags is the one, and inside you can have any number of tags. So let me do something here. In variables, what I do is variable tags. This type is map and default value equal to, okay, name of the project. What is this? Timing. Environment, like dev environment. Terraform true. Okay, I'm creating multiple tags here. Okay, now I will refer these tags in this VPC. Tags equal to var.tags. So map is nothing but key value pair. Okay, this is the key, this is the value, this is the key, this is the value, this is the key, this is the value. So now we cover two types of variables. This is the default, or let me remove from here and keep it inside TF vars. Tags equal to like this. Okay. Now var equal var.tags, and inside this tags here, if I do var.tags, so what will happen? This name will be coming from here. For example, dev timing true. Okay, let us apply all this and then we will check what will happen. So instead of tags here, var.tags. var.tags. And everywhere I will apply var.tags. Okay, and public, this one is var dot public subnet CIDR. Now let us apply and then check what is happening. Public CIDR we didn't give. Give public subnet CIDR 10.0.1.0/24. Changed the name of public, right? So I just come here and then apply this change. Where is this? Line number 45 and line number 67. So our entire Terraform concepts, first we will learn on the VPC, and then finally we can create the project infrastructure completely. Now you go and check here. VPC has the tags. Terraform true, name is timing, environment is dev. And you go and check into the subnets. Here also the name is timing. So what I just want to do is I need to merge the values. Terraform merge tags. So when you do like this, what will happen is you do like this. Match var dot tags. This one. I'm doing var dot tags. Inside that, I'm merging with merge var dot tags and merge name equal to, you can give a separate name for this. Timing. Okay, similarly, just keep here and then here name equal to public subnet. So what will happen is in runtime, it will fetch all the variables related to the tags. And the name will be merged with the given name from here. Okay. And similarly, you should do this everywhere. What is this one? This is private subnet. And here, this one, it is timing internet gateway. So like this, you should do. Now you go and apply the change. Terraform apply. It has something error at vpc.tf 10th line. Okay. Now, if you say yes, you can see public and private subnet, but the other tags will be there. like Terraform true and environment temp. So this is the general best practice. Keeping the tags in a central location like this in variables. And then whenever you need, you can merge with the name like this. Okay, so this is the map kind of variable. Now let us do everything. Private subnet CIDR. Keep it in terraform.tf vers 10.0.2.0/24 and replace this with var.private subnet CIDR. This one we will replace this with variable internet CIDR. Okay. You can keep the description also. It's not here. Okay, here internet CIDR 0.0.0/0. Replace this with var.internet CIDR. And this one var.internet CIDR. And that's it. So we don't have any hard-coded configuration. Here you can just keep public route table. Here we will keep timing NAT gateway. Here we will keep private route table. That's it. So now our configuration is little clean. Okay. We are maintaining the values in variables and providing the default values through terraform.tf and we are keeping the tags in a central location. So the same tags will be applied for every resource. Tags are very important while filtering the resources. And then we are merging each resource name with the centralized tags. Okay, so that's it. Now, if you do the apply, then it will not give any error. Or it will change the resource names. Okay, you can see it is changing the resource names. Yes, that's it. So this is the map variable. This is the map variable. Now let us see the list variable also. So let us create the ALB, Terraform ALB. Take this and create another resource called alb.tf. Here I'm creating ALB, AWS load balancer. And here you can give a name ALB and the name can give timing ALB. You can see this is Boolean. So what we can do, come here and create a variable internet type equal to Boolean. It is capital B. Boolean variable in Terraform. Yeah, type is bool. Okay, just internet equal to true, and then refer this inside ALP as var dot internet. Okay, load balancer type, since you can keep this inside a variable lb underscore type. Okay, create a variable here, variable lb underscore type equal to string, and keep this in terraform.tf vars value here. Okay, and what else? Here you can see this is a list. Okay, security groups is a list, and this is a list. If something starts with braces like this is a list. So we need to give subnets. What are the subnet IDs here we should give? Okay, so here should be agent. Okay, we need to give the subnet IDs. We need multiple. So the list variable should be given here as variable subnet IDs. Type is list. Okay, here inside terraform.tf vats, you should mention it as subnet IDs equal to like this in braces. So what is the subnet ID we have is, let us take this public subnet. For now, I'm doing the hard coding. Okay. And let me take another subnet. Okay, so like this, the list you have to mention in braces with comma separated. Here you need to mention this as var dot subnet IDs. Similarly, security group ID also you should mention. So there is a default security group for every VPC. I will take this for now. This is our VPC ID. It is 759. So let me take the security group. This is the default one. Let me take this. For now, I'm hard coding. In future classes, we can see how can we do it more. Security groups. So since this is a list, I need to create a variable security group type equal to list. Here, keep this with var dot security groups. Okay, so I just want to demonstrate you how you create the different kind of variables, string, map, boolean, list, and let us try for any other number. Go to the documentation here, any number. Yeah, timeout. Okay, you can see there is something called ideal timeout. This is a number actually. You can keep this. You can keep this ideal timeout, var dot timeout, and inside variables, just mention variable timeout type equal to number. Okay, inside Terraform.tf first, you can mention timeout 60. Okay, that's it. We have seen all kind of variables. Now you go and check Terraform apply. Var security groups. Haven't we mentioned this? Security groups we already mentioned. Side variables I didn't mention. Variable security groups. Type equal to list. Now Terraform apply. So there is some error. Oh, it's already there. Then we should not face this error. Security groups should be here. Okay, there is some spelling mistake. Terraform apply. Another error. lb.tf line number 11. Okay, we don't need this. Just remove this. Okay, now it is getting created. So that's it. You can declare multiple kinds of variables like number, string, map, and then Boolean. You provide the default values through terraform.tf vars. Okay, and you can override those values from the command line. Okay, we can stop till here today. And we can accept some questions.